Good morning. Today we are going to discuss about data structures through C++. In that we are going to discuss about Unit 3 concepts. So these are the few topics related with the data structures through C++ under the Unit 3. So these are the topics related with the autonomous syllabus. So in this we are going to learn about so what is a tree, what is the definition, and what is the terminologies, as well as so what are the types of trees, what are in that, so what is a binary tree, so what are the properties, and what is a ADT representation, and what is a linked list representation with the help of a tree, and what is the traversal techniques we are using, and what is a threaded binary tree, and the applications of queues, as well as insertion as well as deletion of heap sort. So first of all, introduction to trees in data structures. So as we all know that, so by the name itself, we all are very familiar with the tree structure. So it will contain a root, branches, as well as leaves. So here also, so what is the main purpose of learning these trees in a these trees as a topic of your professional courses? So when we are supposed to tell that we wanted to access some data, so which is stored somewhere, so we can access the data physically, that is normal cases. But if we wanted to access the data from our computers, so which is stored in some certain memory location, so we can access the data in a two ways, that is linear form as well as non-linear form. So first one is linear form, that is nothing but if we wanted to access some certain data, I wanted to go according to a sequence, so which we are calling as a linear. So non-linear comes related with a term called as a random, so where I can access the data at which time I want and at which place I want and what is the exact content I just require. So for that sake we wanted to study about trees. So and the terminology is related with the data structure. So this tree is a non-linear data structure. So before that, what is this node? So actually we have seen that in a linked list representation as well as linear representation. What is a node? It's just a collection of elements. So here, in order to represent a tree, we will use nodes. So next, so this tree is a non-linear hierarchical data structure. And next, it is a collection of entities known as a node. So next here, so always each and every tree will have a root. And with that, if I want to have the branches, so I just wanted to know the connectivity, how root is connected to branch. Okay, so here, so whatever the attachments we are using, the branches, so those are called as a child. So how we are making a connection? So here we are using some sort of a branch to connect from root to a leaves. So here, so this child is represented as, this child is representing as this child, I can tell this as, this is my leaf node. Okay, and this is my root node. So here now I want to have a connection, so that only I can access the data. So here I am providing a connection from root to my branch node. So this root providing the connection from root to my branch node. So I am using some sort of a arrow indicator. So this arrow indicator is called as a edge. So next, for a tree there will not only be only one branch, so they can have a multiple branches. So for one branch I am adding sub branches. See here, you can see that. So this is your main branch. So So for this main branch, you are having some different sort of 3 branches. 3 small branches. For 3 small branches, you are having certain leaves here. Okay, so here also for this branch, so this is my root, this is my main branch. For this main branch, I am supposed to add some certain sub branches. So anyway, any form of connectivity, I will be only using this arrow marks. Okay, so these arrow marks are called as a edge. So that means to provide a connection from root, that is nothing but from one node to another node, we will use a edge. So next is, whenever we are talking about data structures, we have to remember the linear data structures. So this arrays so here this arrays, linked list, stacks, queues, all this comes under a sequential as well as linear data structures. Okay, so next thing, so in order to perform any kind of a search techniques using the sequential data structures, we will have the time complexity is going to be increased. So in order to stop that time complexity, we are going with the non-linear data structure. So to stop that means to decrease the time complexity. For that purpose, we are supposed to use a non-linear data structures. For example, I just wanted to access some certain folder on my desktop. So or I just wanted to access some kind of a folder is present in my E drive. So by default, everybody is having a local drive C, D as well as E. So if I wanted to access in a linear form, first of all I just wanted to access through C drive. Next I just wanted to access D drive. Then I want to go with the E drive. But now, so by using a non-linear, there is no such kind of necessity. So directly I can use my last, like I can directly go to my certain specified area and I can find my data, so that it will be very easier for me. So now the main definition of non-linear data structure is, the trees are non-linear hierarchical data structures that consist of nodes connected by edges. So this is the, so here you can see that yes, just now we have represented nodes connected with edges. Okay, so this is the specified definition of a tree. So in order to analyze the tree, so by the means of definition, we are also having some specified specifications. Like in a tree, we have seen that it is having a branches, but that branches it is having a sub branches. So like leaves, all those things are present. So but here, so tree also having different terminologies, not only the root node or child or parent node or edge, we are having some certain specifications. So let us see what all those things. So whenever we are talking about, so already we have studied about a node and edge and root. So in node, we are having some specified specifications. See here, the last node. So that means in previous classes we have seen, in previous slide we have seen that it is having a root, child, parent as well as child node. So that last node of each path is called as a leaf node. So that child node is called as a leaf node, or it is also called as a external node. And next thing, so it is also having a internal node. So internal node means what? So always the leaf node is called as the external node, and internal node we are calling as, so parent node will become as a internal node. So next, so these are the few terminologies: height of a node, depth of a node, height of a tree, degree of a node, and forest. So height of a node means we can consider number of edges from the node, that is nothing but from starting of the node to a leaf node, and depth of a node means from root node to all the leaf nodes, and height of a tree also can be considered from a root node is concerned with the leaf node. So always the root node is concerned with the leaf node. So by the analysis of a depth of a node only, we can identify the height of a tree. And next, degree of a node. So total number of branches of that particular node. So as we are talking about a node, degree of node, not a tree. So degree of node means total number of branches of that node. So I will show you in brief. Suppose for example, I am having some particular main root node. Okay, so now I am just connecting with some other specified two branches that we are calling as a children. So here, now tell me the degree of a node means, see here, the degree of node is the total number of branches of that node. So here how many branches I am having? So I am having a 2 branches. So 2 branches are nothing but 2 edges. So if I am suppose I am having one more in this. So now, so the degree of my node is what? 3. And here, so let us consider the degree of this node, last node is nothing but 0 because it is not having any branches. Okay, so the degree of this node will become as a 3 because it is having a 3 branches. Okay, so the degree of this node will become a 0. And next, so forest means the collection of disjoint trees. So disjoint means, so in a like previous class you have seen a one tree. Okay, suppose I am having one specified tree here. So this is a one separate tree. So there is no connection between these two trees. Okay, so this is nothing but disjoint trees. And next, here you can see this is some specified structure I am representing. So this yellow color line is representing the edge and these circles are representing the nodes. So here I am having a one root node. So this we are calling as a root node, and these are the parent node and these are the child nodes. Okay, so at this stage, so I am having a 4 child nodes and 1 root node and 2 parent nodes. Okay, so 2 parent nodes. So here whenever I just wanted to represent, so what is a parent, what is a child? So just now I said you that, so here A is having, like A is giving this property, that sharing this properties to B as well as C, as well as here B is sharing its properties to D as well as E. Okay, so that is called as a parent. Okay, if suppose if I am not having this node, okay, so that means I am not having a right node. Okay, I am having only left node. So this is also called as a parent. Okay, now so root node, parent node as well as a child node. Next, what is the child node means? So here I told you this D, E, F, G are the children. So D, E are the children of B and F, G are the children of C. So again, so here by default B and C are the children of A. Then what is a sibling? So here we are telling that, so at a certain level, so at a particular level, when I just wanted to differentiate, or I just wanted to differentiate the parent node as well as sibling means, so here my parent node, so whatever I am talking or I am showing you, the parent node is nothing but here B and C are the parents. And what is the difference between sibling and parent is, so sibling means at same level. So just like, see, my mother is having a 2 children. So these are called as a sibling. Okay. And what is the difference? So of course you can tell that, so for one parent we can have multiple siblings. Okay. So now suppose I am having this one more this thing. Okay now. So this is what? So now B and C are the siblings of what? Of A. Okay. So now here D, E are the siblings of B, and F, G are the siblings. So that means these two are at same level. Okay now. So when these two are, so when the child is, so when multiple, more than one child is coming from same parent, so those are nothing but sibling. So child means child, so we can have 1 or 2 or 3 or 4, but if it is of 1 also, we will call it as a parent only. Okay, but siblings means you should have a more than 1. Okay, so otherwise we will call it as a child. Okay, so just analyze the difference. So now, so we are going to discuss the next terminology is about internal nodes. So what is the internal node? So in a previous slide we have discussed that, B and C are the parents. Okay, so that means which are sharing the properties. So if the same scenario wants to exist in a programming language, how it will exist? So this is a main class, or we can tell this is a main function, and these are the sub functions. Okay, so here that means, and this is a, in this sub function we are having two more sub functions. Okay now, so like that only. So here internal nodes means what? So here B and C are called as a internal nodes. Okay, D and E are not called as the internal nodes, only B and C are called as a internal nodes. So if suppose the last stage, so this stage, okay, so at this stage, so my tree is having 3 levels. Okay, so that means root level, parent level and child level. So if I am not containing this thing means till here only. So now what is my internal node for B and C? Then A will become as a internal node for my B and C. So now what is the internal node for my D and E? B is going to become a internal node for my D and E. So this is a internal node. So sometime by default, if there is a have more than one nodes means it is also called as a internal node. So next is a level. So what is the level of a tree? See, in uppercase we can see in this diagram, in this structure we can find. So this is the first level. So this is my second level. So this is my third level. So here, whenever I am going to analyze, so just analyze about the array data structures. So array specifications. So the indexing of array always starts with a 0. Okay, 0 to n minus 1. So the level of tree is also specified as a 0 to n minus 1. Suppose I just wanted to connect it. Okay, so I can tell how I can represent the level. So if there is a having connection from root node to child node, then only I can tell it is having a 0 level. Root node is having a 0 level. My child node is at a first level. Okay, so like this. So by the help of a edge. So this part is called as a level now. So here it is having a, this 0 is nothing but a root node. So this is my child node. Okay, so here the root node is at a level 0 and child node is my at a level 1. So I am connecting another branch. Now I am having a 2 branches. That is nothing but for my root I am having left child as well as my right child. Okay, so that means this leaf nodes are level 1 and root node is at a level 0. So if I am adding extra, okay, extra nodes. Okay, now so this is my second level. Okay, so simply I cannot tell. If I am having a connection only, I can tell it is a second level. Okay, so the level of a tree, there is we cannot define that if it is only, see here only my left branch is having the children, my right branch is not having a children. Okay, but this is also considered the level of tree means I will consider from top of my tree to bottom of my tree. So here, so that's with 0, 1 as well as 2. So this way. And next thing is height. So what is the height of a tree? So in a previous classes we have seen that. So level is, so it is just a opposite. So if I wanted to analyze in a previous slide, I just wanted to analyze what is my level of A means I will tell the level of A is as a 0. And what is my level of B means level of B is 1. Okay. So what is the level of D means level of D is 2. Like this, in this way I am just going to confirm. And what is the height of a tree means, whenever I just wanted to talk about the height of a tree, so here it is just opposite. So now the height of D is 0. The height of E is 0. The height of A is 2. Because why we are considering from top to bottom? Because whenever we are analyzing the height of tree, so always starts from 0, because whenever you want to measure some particular person, you will not tell that from say like whenever I just wanted to calculate the height of a person, so whether I will just go with the from top to bottom or bottom to top, so definitely I will just go with the bottom to top only. So he is just 2 centimeters old, 2 meters old, 5 meters old, 10 meters or 100 meters. So like that I am going to calculate from top to bottom, bottom to top. So that means for every living creature we are supposed to calculate the height as the bottom to top. So that's why the height, the tree is also we are considering as living organism. So that is the reason. So here we are considering the height of a tree is also from bottom to top. So always the height of leaf nodes, okay, the height of a leaf nodes is 0 and the height of the parent node is 1 here. The height of root node is 2 because I am having only 3 levels. So that's why that is nothing but 0 to 2. Okay, so 3 levels means 0, 1 as well as 2. So that's why here, so if I am having suppose one more level means it is considered as a like height of a tree is 3. And next is the depth. So next is depth. So if I wanted to talk about a depth, so depth as well as the level of tree both are same. Okay, so how can I differentiate both? How can I tell that both are same? It is not. So depth, the terminology is different, the level, the terminology is different. So just glance over this definition once for all. So here the tree, in a tree many edges from root node to a particular node. Okay, so see here, how many edges for this my root node? 2 edges. Okay, so what are how many edges for my B node? 2 edges. So what are the how many edges for my C node? 2 edges. And tell me. So now I wanted to calculate the depth of A. Okay, so depth of A means how many it is having? 1 as well as 2. Okay, and depth of B, here only 1 na? So that's why the depth of B is 1. So depth of D means 0. So next is path. So path is nothing but the way we are going to travel from one place to another place. Okay, so what is the direction and in which way we are supposed to travel. So here I am traveling from A to B. So that means I am going to write like A tends to B. Okay, I am having a connection here. Okay, now so if I wanted to travel to E means A to B I will just travel, and B to E I will travel. Okay, so if can I travel directly to G without going to C? No, I cannot travel. Then you can raise a question. So even I am not traveling from A to G directly, how can you tell that this is a non-linear data structures? So here by accessing the data, because what is happening here, so if I wanted to access this data, already my sub module is connected to my main module. So definitely when I am calling my main function, automatically my sub function will be accessed. So like this I am going to specify my path. So next subtree. So whenever we are considering about this tree, so here all this is called as a left side representation and this is called as a right representation. So this is called as a left subtree and this is called as a right subtree. Thank you for watching.